Good morning, students. This is next topic in complex compounds chapter, that is valency bond theory in complex compounds. This theory was proposed by Paulis. Uh, this theory explains shape of the complex compounds based on electronic configuration. Means by using electronic configuration, we can say the shape of the complex compounds. According to this theory, that means postulates, the metal in the complex compound loses electrons and form vacant orbitals. We know that metals attach with ligands. Every metal possesses positive charge because metal is what it loses electrons. The vacant orbitals of the metal ion undergoes hybridization based on number of ligands. That means after losing electrons by metal atom, then that metal ion having vacant orbitals, those vacant orbitals only undergoes hybridization based on number of ligands. Next point. If the complexes with sp3 hybridization, then its shape is tetrahedral. That means if the complex compounds possess sp3, then its shape is tetrahedral. If it is dsp2, then its shape is square planar. If it is sp3d, then its shape is trigonal bipyramidal. If it is dsp3, then it is square pyramidal. You should remember all these hybridizations and shapes. Next, this is important point. If ns, np and d, that means all are present in same orbit or same shell. That means if all orbitals present in same shell involves in hybridization, then it is called outer orbital complex or high spin complex. If n-1d, ns, np orbitals involves in hybridization, then it is called inner orbital complex or low spin complexes. These 2 points are very important points. If ns, np, nd orbitals involves in hybridization, that is called outer orbital or high spin. If n-1d, ns, and np orbitals involves in hybridization, that is called inner orbital or low spin complex. And last point regarding this one, that is in the presence of strong ligands. See, among all ligands, CO, CN, these two are strong ligands. When these ligands attach with any metal atom, those ligands act as strong ligands. In the presence of strong ligands, the unpaired electrons present in the metal ion will be paired against Hund's rule. Here one more point is there. Other than these two ligands, rest of the ligands are weak ligands. But one exception is there. Not one, two exceptions are there. They are NH3 and C2O4 minus 2. That means ammonia ligand and oxalate ligand. When these two ligands attached with cobalt only, when these two ligands attached with cobalt metal, not other metals, when these two ligands attached with cobalt, then these ligands act as strong ligands. There is no specific reason behind that one. You just simply remember that point. I repeat once again, except CO and CN, all are weak ligands. These are only strong ligands. Exceptions are ammonia and oxalate when these two ligands attached with cobalt metal. Then only those two ligands act as strong ligands. Otherwise, these ligands act as weak ligands. That means when these ligands attached with any metal, then those act as weak ligands. That is the meaning of the point. These are the postulates of valency bond theory. Now we will discuss some examples, then we will get clear idea about this one. This is also one of the very important topic in this chapter. See, first example, CONH3 6 times plus 3. That means one complex ion is given. This is cationic complex because it possesses positive charge. First, what we have to do? First, we have to find oxidation state of metal. That is the first step. Every time we should find oxidation state of metal. How can we find here? This is X. X plus how many ligands? 6. This, since NH3 is neutral ligand, so that its oxidation state is 0. This is equal to plus 3. Finally, X equal to plus 3. That means the metal exhibit plus 3 oxidation state. What is the metal in this complex compound? CO. So CO plus 3. For that ion, we should write electronic configuration. What is the electron? Actually, argon electronic configuration. Argon 4s2 3d7. 4s2 3d7. But plus 3 means we should remove 3 electrons. Out of 3 electrons, 2 from 4s. Why? Because this is outer orbit. And 1 from 3d. So 4s2 becomes 4s0 and 3d7 becomes 3d6. And one more point is there here. That is, we can write electronic configuration like this. 4s0 3d6, you can write it as 3d6 4s0. While writing, this is also correct. Next, here we should apply the conditions of valency bond theory. Postulates of valency bond theory. What is the point? In the presence of NH3 ligand, I told you just now here, this NH3 acts as strong ligand, so that the unpaired electrons will be paired in metal ion. See, this is 3d6. This is orbital representation. 4s0. Now, how many unpaired electrons? 4 unpaired electrons. Now, these 4 unpaired electrons become paired, so that this orbital contains 2 and this orbital contains 2. Finally, it becomes, this 3d6 contains 2 vacant orbitals and 4s0 is also 1 vacant orbital. Now, one important point is there. That is what, regarding valency bond theory, the vacant orbitals of the metal, vacant orbitals, not these orbitals, these are electrons orbitals. The vacant orbitals of the metal ion undergoes hybridization based on number of ligands. Here number of ligands are how many? 6. That means we need 6 vacant orbitals. We need 6 vacant orbitals. So out of 6, 2 are present in 3D. This is 1, this is 2. Next 1 is present in 4s. Still we need 3 vacant orbitals. For that purpose, we have to take 4p0 because this cobalt is present in 4th shell. 4th shell contains 4s. Along with 4s, 4p, 4d, 4f orbitals are also present. So that we should consider this one also. So we need how many vacant orbitals? 6. 1, 2, 3, 4, 5, 6. So these vacant orbitals, only these vacant orbitals involves in hybridization. 2 from D, 1 from 4s, 3 from 4p. So finally D2. Why D2? Because 2 orbitals involved. D2 sp3. D2 sp3. This is the hybridization for this complex compound. So what is the shape of the complex compound? D2 sp3, octahedral. Next, in this case, see, this is inner orbital complex. Why it is called inner orbital? Because in this case 3d 4s 4p, that means n minus 1d ns np, that means 4 orbitals, 2 from outer orbital and 1 from inner orbital. See, this 3d is present in 3rd shell, but 4s and 4p present in 4th shell. That means these are outer orbitals, but this is inner orbital. Along with outer orbitals, this inner orbitals also involves in hybridization. That is why this is called inner orbital complex. Next, this is also called what? Low spin. Why it is called low spin? Because if there is no unpaired electron, after pairing no unpaired electron, that is why it is low spin. Suppose if unpaired electrons are present, if more number of unpaired electrons are present, that is called high spin. Next, one more example, then you will get a clear idea about this one. K4FeCN6. What we have to find? We have to find a oxygen state of metal. What is the metal here? Iron. Iron oxygen state how much? 4. 4 is what? 4 into potassium how much? Plus 1. 4 into plus 1 plus X plus cyanide how much? Minus 1 equal to 0. So x minus 2 equal to 0, x equal to plus 2. That means iron oxygen state plus 2. Then what is there? First what we have to write? We have to write every time electronic configuration for that ion. Argon 4s0 3d6. We can write this one as like this 3d6 4s0. Now cyanide, I told you, cyanide and carbon monoxide, those are acts as strong ligands always. So these unpaired electrons becomes paired because since the cyanide is a strong ligand. Then it contains two vacant orbitals which contains 3d orbital. So 2d orbitals, 1s orbital. Here also we will take 4p orbital because we need 6 vacant orbitals because here 6 cyanides are present, 6 ligands are present. So based on ligands only vacant orbitals undergoes hybridization. So its hybridization is also how much? D2 sp3 as in previous case. Whether it is sp3 d2 or d2 sp3, what is the shape? Octahedral. Why it is diamagnetic? If the no unpaired electron is present, that is diamagnetic. Next here also inner orbital because along with 4s 4p 3d orbital involved. This is also diamagnetic substance. So what type of questions we are facing regarding this one? Complex will begin whether it is inner orbital or outer orbital. We have to find like that, or whether it is diamagnetic or paramagnetic. So we have to find like that. So we will face such type of questions. Which of the following complexes are inner orbital, or which of the following complexes are outer orbital? Which of the following complexes are low spin? Which of the following complexes are high spin? Which of the following complexes are paramagnetic? Which of the following complexes are diamagnetic? For all these cases, we have to follow this procedure only. If you learn this procedure, we will able to solve any type of question. Next, one more example, then you will get clear idea. That is NiCl4 minus 2. So first what we have to find? We have to find electron oxygen state. X plus 4 into chlorine, how much? Minus 1 equal to minus 2. X minus 4 equal to minus 2. X equal to minus 2 plus 4 3 plus 2. So what is the electron configuration for Ni plus 2? Argon 4s0 3d8. Since Cl is weak ligand, so that these two unpaired electrons will not pair up. We need how many vacant orbitals? 4 because ligand number is 4. So that we have to take 4p only. If suppose 6 ligands are needed, what we have to do? We have to take 4d also. That means based on ligands only we will take vacant orbitals. Then sp3 hybridization will come. Its shape is tetrahedral. Paramagnetic because unpaired electrons are present. This is outer orbital because only 4s and 4p. That means ns and p orbitals involved in hybridization. And high spin, I told you already, if unpaired electrons are present, that comes under high spin. Next, one more example. NiCO4. CO neutral ligand, so that its oxygen state is 0, automatically this oxygen state is also 0. So that Na electron configuration is argon 4s2 3d8. We can write like this 3d8 4s2. CO is what? Strong ligand, so that all these unpaired electrons will be paired. After pairing, here one vacant orbital is present, but these two electrons are present here. But what we have to do, every time in hybridization, s orbital must be involved. I repeat once again, every time in hybridization, s orbital must be involved. After pairing these two electrons here, then this orbital will be vacant, but these two electrons remains in 4s orbital. So for to involve for the purpose of involving hybridization of s orbital, we will pass these two electrons into this orbital. Then 3d8 become 3d10, then 4s orbital become vacant. 4s0, 4p0. Here also we need how many vacant orbitals? 4 because ligand number is 4. So sp3. sp3 means what? Which shape? Tetrahedral. Next, this is diamagnetic because there is no unpaired electron. This is outer orbital. Why? Because only ns and p orbitals are involved. Next, one more example. FeH2O 6 times. FeH2O 6 times. What we have to do? Find H2 is neutral ligand, so that its oxygen state is 0, but here complex plus 3, so that Fe exhibit plus 3. Its electronic configuration argon 4s0 3d5. So 3d5 4s0. We have to write like that. Since H2 is weak ligand, so that these unpaired electrons will not pair up. Here we need 6 vacant orbitals because 6 ligands are present. That is why we have to take 4D also along with 4P. 4S0, 4P0, 4D. So out of 4D orbitals, we have to take only 3. We have only 2 because already one is present in S orbital, one vacant orbital present in S orbital, 3 vacant orbitals present in P orbital, and 2 vacant orbitals present in D orbital. So hybridization is sp3d2. Shape is octahedral. Unpaired electrons are present. Even if one unpaired electron is present, that also comes under parameric. Here NS, NP, and D orbitals are so that it is outer orbital. Like that, we can calculate hybridization shape, diamagnetic or paramagnetic outer orbital, inner orbital regarding any complex. Next, drawbacks of this theory. What is the drawback? It could not explain color of the complex compound. Next, it could not explain stability of the complex compound. It could not explain strength of the complex compound. It could not explain shape and hybridization of the CuNH3 4 times plus 2. Actually, experimentally, it has DsP2 hybridization and square planar shape. Experimentally, but theoretically, it is tetrahedral shape. Experimentally, it has a DsP2 and X square planar, so that it could not explain about shape of this one. This is about drawbacks of valency bond theory.